here we go. Let's finish solving this, of course. I hope we all know 6 squared is 36. What's 15 squared? 225. And let's subtract off the 36. So we'll be at 189. All right, now I know you know we're going to get rid of this squaring with the root. We all know that. Okay, remember, on your quiz in the homework, we keep saying 2 styles of directions. Some say exact answers, then some say you can use your calculator and round to whatever. If I want an exact answer, I'm not going to punch that in and give some random decimal answer for it. I'm going to simplify the radical. So the biggest perfect square that goes into here, just as 9, goes into there 21 times. What's the square root of 9? 3. So I'm going to put 3 square roots of 21 for my side. That is the exact answer. And most of the time, like 90% of the time, we're always going to ask you for those exact answers. This is the only new piece of the puzzle that I am adding to all of your triangle stuff today. You are going to have to find some missing sides with the Pythagorean theorem. We're still going to use SOHCAHTOA, of course, and write out all the trig functions. And there's a couple little calculator problems for you at the end. Okay, here's the Debbie Downer side. Read the directions. 6. Whew, I need all 6. Sine, cos, tan, and all the reciprocals. Okay. Not difficult, but time consuming. So, of course, on this one, we need our hypotenuse this time. I'm going to call it C. So I'm going to do my 6 squared plus 4 squared, C squared. All right, little mental math here. 6 squared is 36. What's 36 plus 16? 52. I think I heard it. Let's get rid of the squaring with the root, of course. Now again, the directions say exact value, so I'm not going to give a rounded decimal. I'm going to simplify this radical. I know 4 goes into it 13 times to get exact. Square root of 4, of course, 2. So just up here in the picture, I'm just going to label it. It's 2 square roots of 13 then. Now, I left you some room, but still I'd kind of write a little bit small because we have to do all 6 trig functions. I'm going to start with sine. Of course, we know sine is opposite over hypotenuse. So opposite of theta is 4. Hypotenuse is that 2 root 13. Now, of course, I'm going to reduce. I'm going to simplify. I got a couple problems here. 4 over 2, that's easy. And of course, we do have to rationalize the root 13, which I'm going to do in a minute. But work smarter, not harder. I'm going to go ahead and do cosecant really quickly. Because like, oh yeah, cosecant. If I flip this, if I do the reciprocal, of course, I won't have the radical on the bottom. Okay, but I got to back up the truck here. Some of you I know can do the rationalizing in your head, of course. I'm going to write it out on the first couple for us. So we're going to end up with 2 square roots of 13 over 13. All right, we're 2 out of 6. Done, 2 out of 6. Let's do cos next. This is just the tedious part of it. So cosine, of course, adjacent 6 over that hypotenuse, 2 root 13. Now, really, it's going to be kind of the same process. I'm going to reduce 6 over 2. I'm going to make that 3. Yes, I know that needs to be rationalized. I know some of you can just do that in your head. Fine. I'm going to go ahead and list secant right now, because when I do the reciprocal, that root's on the top. So rationalizing needed. I am going to back up, though, of course, rationalize this guy. I don't care on your homework if you actually put the root 13 on there. I know a lot of you can do that in your head. All right, last but not least, we got 4 out of 6. We need tan and cotan. So tan, opposite, 4, adjacent 6. Oh, I like it. I like it. No radical. All I got to do is reduce it. And of course, cotan then is going to be our reciprocal, 3 over 2. So take a look. Did I teach you anything new? No, all we're adding to this is we're kind of getting away from always being on the 30, 60, 45, 45, 90 and having to do some Pythagorean theorem. Okay, sketch a right triangle corresponding to the trig function. Use Pythagorean theorem to get the third side, and then find the other 5 functions, because they gave you 1. I mean, you could list cotan right now. It'd be pretty easy, and I'm going to do it in a minute. Now, right triangle. I am not on the 4 quadrants. It doesn't matter how you draw your right triangle. Just make yourself a right triangle. Theta. Doesn't matter where I put the theta. If I make it the bottom acute angle or the top one, because I'm standing over here on the left, I'm going to make it the bottom one. Now remember, trig functions are ratios comparing fractions two sides on the triangle. So tangent, of course, is your opposite adjacent. So I can label accordingly on my picture. Now I know the opposite 5, adjacent 2. No shock here. We're going to have to get our third side with that Pythagorean theorem. So I'm going to do 2 squared. And some of you I know can do this in your head. 5 squared, c squared. I like that left-hand side because I've got 4 plus 25, 29, which is prime. So I'm just going to go ahead and label on the picture square root of 29. Now, same thing, it wants the 5 remaining trig functions. They gave you tan. I'm going to do them a little out of order. I'm going to go ahead and list cotan because I can just quick and easy do the reciprocal of 5 halves. So we got that. 4 to go, 4 to go. I'm going to do sine now. So sine, of course, opposite hypotenuse, opposite 5, hypotenuse your root 29. Yes, I know that needs to be rationalized, and we will, but I'm going to go ahead and list cosecant, because when I do the reciprocal, the root's, of course, on the top. So let me just back up here. I'm going to rationalize sine. So my sine final answer is going to be that 5 square root of 29 over 29. Okay, whew, okay, we're almost there. We need cos, of course, and secant, or the finals. So cosine adjacent, which is 2, hypotenuse, that root 29. Bless you. So kind of the same spiel. I'm going to go ahead and do the reciprocal right now unless my secant, because then my root will be on the top. I won't have to do any rationalizing for secant or anything fancy. I do need to back up though and get my final answer, a cosine rationalized 2 square roots of 29 over 29. Yeah. So I'm going to be honest with you. The front side, and your homework's only a front and a back, the front side is the worst because the first handful of problems ask you like for all 6 trig functions or all 5, the remaining 5, etc. Miranda.
So do we not simplify the square root term?
You can't because it's prime.
Okay.
Yep. I thought about it, but I can't because it's prime. All right, let's do another one of these guys. Again, you can draw your right triangle however you want to draw your right triangle for this guy. Get fancy and draw it this way. Now again, it doesn't matter which angle, which acute angle you label as theta. I don't know why. I think it's just out of habit. I usually do the bottom one. And we have cosine this time. So your 2 sides they gave you are adjacent and hypotenuse. So label accordingly. Adjacent, hypotenuse. Of course, we have to find our remaining side. You can call it X, A, B, whatever you want to call it. I'm going to call it A. Because I usually call it A because I'm thinking about my Pythagorean theorem. A squared plus B squared equals C squared. So A squared plus 3 squared. All right, 49 and 9. I've got a little mental math here. So if I take 9 off of 49, I'm going to be down to 40. And we're going to root it. And I can simplify the square root of 40. Of course, our perfect square 4 goes into there 10 times. So I'm just going to label on the side up here, square root of 4, 2. And we get that root 10. Okay, all right, let's list the remaining 5. So much fun. Again, I'm going to work a little out of order. Because they gave you cosine, let's do secant. Nice and easy, just a little reciprocal work there. I like that. Okay, let's do sine. And of course, while I'm at it, let's do cosecant. So sine, of course, opposite hypotenuse, opposite theta 2 root 10. Hypotenuse 7. Now this time our sine answer came out nice, which means cosecant's not. Okay. So I'm going to flip it. Because of course you have the radical now on the bottom. So I'm going to rationalize. I don't care about the 2. The 2 is not a problem to me. It's just that square root of 10. So I'm going to put my final answer, 7 square roots of 10. What's your denominator? 20. Square root of 10, square root of 10, 10. 10 times 2. And I always double check like 7 over 20. Can't reduce and it can't, so I'm going to leave it. Okay, all right, here we go. So we need, of course, we have sine. We've got the cosine. We need our tan. And then, of course, that's little partner in crime, cotan. All right, TOA, opposite, 2 root 10, adjacent. Now, of course, since tan came out nice for us, that means cotan will not. Can never win on both, it seems like. So of course you would have to rationalize this. Like, I know a lot of you can do the rationalizing in your head, which is fine. Put your root 10 on. So we've got 3 root 10 on the top, and we have 20 on the bottom again. So kind of just like the homework. The front side of the homework is definitely the most time consuming because you have to do the remaining 5 or all 6 or whatever. When you get to the back side, just like the back side of your notes, it's nice and easy. Evaluate the following by constructing an appropriate triangle. Is this anything new? Cos of 60? Haven't we been doing that for like the past however many days? So let's draw our 60 degrees. Quadrant 1. Again, I'm just going to ballpark 60 degrees here. I know that looks good. I'm going to make my right triangle always with the x-axis. And we're going to label our sides accordingly. Across from the 60 is root 3. Across from the 31, hypotenuse 2. Would any of those sides need a negative due to the location? No, quadrant 1, everything's positive. Yeah. And all I need is cosine. I don't need all 6. Thank God. Okay, cosine, adjacent, hypotenuse, a half. We got it. So same, the back side of your homework gets easy, just like these. Again, I've taught you nothing new today. Okay. Now, I'm hoping pi over 4 we're just starting to recognize. Pi over 4 is how many degrees? 45. So again, 45 degrees is in quadrant 1 here. I'm going to label the sides accordingly. 45, 1, 1, root 2. Now you need secant, the reciprocal of cosine. So like, all right, I got it. Cosine's adjacent, hypotenuse. We need hypotenuse adjacent. So hypotenuse, adjacent, we got it. So nothing new there. We've been doing a bazillion of these, it feels like. So there's only a handful on the homework, not too crazy, but just to make sure we have those down, because clearly there's a lot of that on your quiz on Friday. Okay, little more of the same, but a little different. So it says you're finding the angle. Okay. And it tells you, remember, in the directions you're in quadrant 1. Here's the thing. They didn't right now give you the angle, 30, 60, 45, whatever, okay? So I gotta kind of do a little investigating, so to speak. So right away, the square root of 3 jumps out at me. I know I'm on a 30, 60, 90 triangle, okay? One thing I don't like, though, I'm like looking at my 30, 60, 90, none of the sides are just plane 3, not square root of 3, plane 3. So first up, I'm like, okay, so it's this form. Because if I rationalize 1 over square root of 3, it's the same thing. Now they tell you in the directions, we're in quadrant 1, so let's get that going. I know it's the 30, 60, 90 triangle. The question is this the 30 or the 60, our reference angle? Well, they give you cotan, inverse of tan. So tan's opposite adjacent. You have adjacent over opposite. So adjacent. Oh, okay. All right. I got it. This would be 2. Now I can tell you, what's the reference angle? What is the angle across from root 3? 60. That is your answer. So one thing you're going to see that we're going to kind of start adding to all this, let's be honest, very repetitive right triangle stuff, is they're going to ask you or have you start finding the angles too. So we're working our way towards that. Now again, directions tell you you're in quadrant 1, so I'm just going to go ahead. Eventually we will be out of quadrant 1. Now this is nice. They gave you tan, so opposite adjacent. I'm going to label adjacent. So it's similar triangle, but this time it's important though to recognize what's your reference angle? 30. Across from the side of 1 is 30. Got it. Got it. Any questions on those? So there's a couple of those. We're going to start adding that into the mix too. But again, I really haven't taught you anything new. Okay. Calculator time, my friends. You're going to hear me start saying this a lot this chapter. It is important that you watch your calculator mode. Because clearly, the first 2 angles I'm giving you are in degrees. They have degree symbols. The bottom 2 angles are in radians. So we are going to have to be switching our modes back and forth. So let me pull up my calculator here. Let's take a look. So I'm in radians right now. I could keep it and just do C and D, whatever, but for the sake of it, I'm going to do them in order. I'm going to go into my mode, of course, and put this back onto degrees so we can type these first 2 in. All right, nothing fancy here. We're just going to hit sine 16.35. I'm going to let you write that down, round to 4. Now, here we go. Cosecant. You do not have a cosecant button on your calculator. So this is where you have to know all those lovely little identities way back in the day we started with. Cosecant, of course, is the same as 1 over sine. So that's how I'm going to type that one in. I'm going to do 1 divided by, maybe if I can get my calculator up here, the sine of 16.35. Now, the bottom two, of course, are in radians. So I'm going to switch my mode quick. Well, maybe not quick. We see how I type this. Put it on radians. Okay, so cos of pi over 16, I can just straight type that in. I'm going to use my pi button. Got it. I'll give you a sec to write that one down. And then, of course, tan pi over 16. This thing, come on, 1/6. There you go. So any questions on your calculator? Now, just a little quick review too before I give you the homework and we get into some other fun stuff here. Wait for it. One other thing too on your homework, you're going to see I threw on there like there's a degree, minute, second. Do you remember where to find that degree, minutes, and seconds? Second, apps has degree and minute in it. You know, I love to complain about Texas Instruments. Do you remember where to find seconds? I'm like, why can't we all put it in the same stupid menu? Alpha plus. Alpha plus for the seconds. Okay, so last thing I have for you. This is going to be fun. So, notice. So fun, I'm so excited for this. So, notice I added this in red on here. You have the world's easiest 8-point quiz coming at you tomorrow. Now, and I even made you a practice one, so you know exactly what the heck I'm talking about here. So remember, we have been using our identities here, like cosecant's 1 over sine, tan is 1 over cotan. We have been using these in the problems. It is important, not as much this chapter, that we have those memorized, especially for the next chapter, chapter 5. And as you can see over here, I'm working on my little arts and crafts project, where I'm cutting out these very lovely laminated identity sheets that you will be receiving. Hopefully tomorrow I'll get them cut out. And at some point in time, we will have this whole thing memorized front and back. Not today though, not today. Don't let that scare you. Don't let it scare you.